Okay, now we see about deBroglie's equation. So, what is the importance of this deBroglie's equation means? So, it is given a basic fundament. It is given a basic fundamentation for quantum mechanics, which exactly says that electron-like particles are having dual nature, and electromagnetic radiation also follows the dual nature. It explains totally with the mathematical expressions. The total quantum mechanics explains every concept in terms of mathematical expressions. So it is the basic foundation for that quantum mechanics. Okay. So according to de Broglie, the electron-like particles shows a dual nature. Not only electron-like particles, even electromagnetic radiation. Electromagnetic radiation means they consist of the particles photons, light particles called photons. So electron-like particles just like photons, protons, neutrons, all particles, all microscopic particles follows wave nature and also particle nature. So he started his equation based on Einstein's equation. So equation of Einstein equation of theory of relativity. So it is a very important theory. Generally you get in physics, theory of relativity given by Einstein with the help of an equation that is equal to mc square. So for this theory he got the Nobel Prize. So it is equation 1. And we know that according to quantum theory, here E is equal to h nu. So here E, both in both equations E indicates about energies. So therefore we can write 1 is equal to 2. That is mc square is equal to h nu. And mc square is equal, we know that h nu is equal to, in the place of nu we can write c by lambda. So here C get cancelled, then lambda becomes h by mc. Here C indicates generally in all these equations speed of light. So de Broglie theory not only applicable for the light particles, it is also applicable all type of particles. Here C indicates only speed of light. But to make it applicable for all type of particles, thus we made some change, that is lambda is equal to h by mv. So this is called de Broglie's equation. So in this equation, if you observe, there is a lambda is present, means wavelength is present. Wavelength is indicates the wave nature, and there is m is also present, mass. Mass also indicates the presence of particle nature. Okay, means totally de Broglie theory supports the dual nature of light, dual nature of electromagnetic radiations, or dual nature of electron-like microscopic particles. And it can be written as lambda is equal to h by, here mass into v means velocity. Okay, So mass into velocity, we can write the momentum. So it can be written as lambda is equal to h by p or lambda is equal to h by mv. M equal to mass. So lambda equal, we know that wavelength. V is velocity. P is momentum. We know that h is the always Planck's constant. H is Planck's constant. Okay, totally. For example, if you want to apply, okay, now we give some applications about it. So this is called deBroglie's equation. Lambda is equal to h by mv. M into v, we can write the momentum. So lambda is equal to h by p. And see here we are taking two cases. For example, in the first case we are taking very small particles, nothing but for microscopic particles just like electron, proton, like that. So apply the lambda is equal to h by mv. So we know that the mass of electrons, protons, they are very less. Electrons are totally negligible. Protons and photons are also having very small mass. For these particles, m is very less. The mass is very less. So here denominator is very less. As the denominator is very less, the total value is, it is considerable. Okay, it may not be negligible because as a numerator, as a denominator is a negligible, is very less value, the total value becomes somewhat considerable. Means lambda value is considerable. Lambda means we know that wavelength. Wavelength is nothing but characteristic of wave properties. Means the electron-like particles, even the light particles are nothing but photons, are also having wavelength which is considerable value. Means they are having some wavelength. Means they are showing wave-like properties. In the case 2, take some big sized particles, that is macroscopic. Macroscopic particles. Macroscopic particles means just example of cricket ball, bullet coming from a gun. Okay, so all these particles. So the cricket ball, bullet, these masses are somewhat somewhat large, and compared to these microscopic particles, the cricket ball mass, bullet mass is somewhat large. Here mass is large means in the lambda is equal to h by mv, the mass value is large. Mass large means in denominator the mass value is very large. In the denominator value is large, therefore lambda will be very less. It is negligible. It is totally negligible. For example, if you take a calculator for cricket ball and bullet and any other particles of macro size particles, due to their large mass, the total value will get very less, which is negligible. Means the macroscopic particles, means the big sized particles are having lambda, which is negligible, but their wavelength is negligible. Means the wavelength is a characteristic of wave property. That wavelength is negligible means there is no wave property for cricket ball and bullet type of particles. Means some particles are having wave properties, some particles are having only particle nature. Okay. When time comes for light, it consists of photons. Light consists of only photons. So that's why it comes in the microscopic particles. So light compulsory shows nothing but electromagnetic radiation shows dual nature. For example, if you see the light consists of particles are called photons. Photons nothing but they are microscopic particles. Microscopic particles means they compulsory shows dual nature, and they are having some mass, and they are also having lambda, mass and lambda. That's why they shows particle nature. They also shows wave nature. Okay. And we already know that, for example, to explain black body radiations and to explain photoelectric effect, we compulsory follow particle nature. We must follow particle nature to explain the black body radiation and photoelectric effect. Already we discussed it earlier. For example, to explain diffraction, reflection, refraction, interference. So all these properties of the light can be explained by taking wave type of nature. Okay. So it is concluded. Finally, we can conclude that electromagnetic radiations must follows dual nature, wave-like properties and also particle nature. This is the first time mathematically given. It is given in terms of mathematical expressions by deBroglie's equation. Nothing but D is also known as deBroglie's theory. So this mathematical expression explaining the dual nature of particles is known as a basic, nothing but a foundation for quantum mechanics theory, which is totally based on mathematical expressions. Okay, now we see the other forms of deBroglie's equation. We know that deBroglie's equation lambda is equal to h by and we also know that kinetic energy is equal to charge into potential. Means, for example, if you take electrons, when they are charged particles, if they are accelerated by some potential, if any charged particles are accelerated with some potential, their kinetic energy will be equal to the charge into applied potential. So here we can write kinetic energy equal charge into potential V. They are not here, we are taking electron volts, they are charged into potential. And so we know that K is equal to half mv square. Of mv square is equal to into V. So mv square, in the place of mv square we can write 2eV. Okay, by multiplying both sides with the m square v square is equal to 2 into m into E into V. Okay. Then what about mv? So mv whole square equals 2m ev. So what is mv now? Root 2m ev. So we apply this in this equation. Now it becomes lambda is equal to h by root 2m ev. Or so in the place of ev we can write kinetic energy. So here now we can write that lambda is equal to h by root 2m k. Okay, these are some extensions for deBroglie's wave equation. Okay, so now we see some problems based on the deBroglie's equation. Okay. Here, it's a problem based on deBroglie's theory. So it is given that, so calculate the mass of a photon. Photon means generally light particles are called photons of sodium light, which are having wavelength 600 nanometers and velocity 3 into 10 power 8 meters per second. So their velocity is equal to the speed of light, 3 into 10 power 8 meters per second. So we need to find out the wavelength. The wavelength is given. We need to find out the mass. And we know the relation in terms of mass and wavelength. Lambda is equal to h by mv. We need to calculate mass. So mass equals h by mv. The mass. What is the mass? What is the lambda? 600 nanometers. We never do the calculation in terms of nanometers. We convert them into meters in SI units, as h is taken in joules into second, minus 9 meters. So what is the velocity? 3 to 10 power 8. So what is the mass now? Here 6.625. So become minus 7, 18, minus 7. Here minus 7, it becomes 10. And by doing this, we will get 0.368 into 10 to the power of right one minus 35. We can write 3.68 into 10 to the power of minus 36. So it's a mass. So what means mass? Mass must be in kgs, because in total calculation we followed the SI method. So కాబట్టి ఇక్కడ వచ్చే mass, it must be in kgs. Okay, take it now. Okay, see in this problem, the kinetic energy of an electron is given 4.55 into 10 to the power minus 25 joules. Here the kinetic energy is given. So the mass of electron is also given. So it is not compulsory to give the mass of electron, because we must know about the mass of electron. In this problem it is given that. If it is not given, we need to write our own. So find the velocity of that electron. So the mass is given, kinetic energy is given. So kinetic energy is given how much? 4.55 into 10 to the power minus 25. So we know that kinetic energy is equal to half mv square. We need to find out the mass. Mass is also given. We need to find the velocity. Now the v square equal to 4.2. What is the mass? Here approximately 2 into 4.5 is 9.1. Comes plus 31. So v square equal 10 power 6, that implies v is equal 10 power 3. So what will be the units? It's very important in any problem to provide the perfect units, as we are taking the total problem in SI units. The mass is taken in terms of kgs, the energy is taken in terms of joules. It means we follow total in SI units. So we must apply the SI units for this answer. That is 10 power 3. Velocity means that is meters per second. Okay, take it now. Okay, see the next one. The de Broglie wavelength. So we need to find the de Broglie wavelength of a tennis ball. Nothing but a macroscopic particles with mass 60 grams moving with a velocity of 10 meters per second. So the de Broglie wavelength, we know that lambda is equal to h by mv. We need to find this lambda. What is h? 34 joule into second. Here mass is given in 60 grams. So already we took the h value in 6.625 into 10 to the power of minus 34 joule into second. Hence we took this in SI method. So it must be in SI method, that is convert it into kgs. Next, it is 10 meters per second. So already it is in SI method, there is no need to change it. It is kgs into meters per second. So finally lambda equals so these twos and become only 1. So here it is approximately we get 1.104 minus 33. So it must be in SI units, that is meters. Okay. So this is the wavelength. This is the wavelength of a tennis ball. So here the wavelength of tennis ball is 1.104 into 10 power minus 33. 10 power minus 33 means it is not at all in the form of wave, because its wavelength is totally negligible. So that's why we can say the tennis ball like particles cannot be in the form of wave. They just have a particle. Okay.